Hello everyone, George here, and in this series we're going to be looking at a book called Game Programming in C++. If you're familiar with my other series where I implemented a ray tracing engine from a textbook, I'm going to be doing something similar with this one where we're going to be going chapter by chapter, and I will kind of tell you how I felt about that chapter, or if there's anything that I thought was really great or maybe not so great. Now, why did I pick this book? That's because I actually thought I was going to be making a big change and start working with the Unreal Engine and the C++ side of it a lot more. However, those plans have kind of fallen through recently. But this book is still really good, and it's got me interested enough that I think I'm going to go all the way through and finish the whole thing. C++ was my first language, my first love, so to speak, in terms of computer programming. I had a book like this thick back in high school, and I can remember trying to read this huge book in the bathtub. And I got all the way, I'd say, about halfway through to where pointers started to become something in references, but it wasn't really until I got to college and I pushed myself a lot further with computer graphics that I really, I'd say, got to an intermediate level with C++. For those of you who are following along, you might want to know if this book is actually for you. And I do have to say this is most certainly not a book for someone who's a beginner. It's squarely on someone who is intermediate level, also someone who's going to be able to read these topics and sort of get what they need from it and then apply it themselves. The book has most of the code in it, and there's a GitHub repository. But personally, I'm the kind of guy who doesn't like to just go into a repository and take code. I rather would try to read it and implement it myself. So if that's the kind of person you are, this book would be good for you. At times, the book will show you code snippets, but sometimes they're out of order. Or maybe they'll describe something and then say, well, if you want to implement this, you'll need to add X, Y, and Z on top of it. So you do have to be a little independent in the language. You have to be someone who can easily go online and look up keywords or something that doesn't make sense to you and figure it out yourself at times. For the first chapter, specifically, they talk a lot about basic game engine design, and that's what we're looking at here on the screen is a successful implementation of chapter 1 in this book. It's using, of course, SDL to do this, and they do not walk you through in the text how to get SDL working with Visual Studio. So that is something you are going to have to look up online, but there are plenty of resources on both the website as well as message boards that explain how to set that up with Visual Studio. Specifically, 2019 is the version that you're seeing me work with right here. From what you can tell, it's very simplistic, but it does require some going from beginner to intermediate area of C++. Specifically, you're going to need to understand classes, but not just how to make a class. You really need to understand inheritance and the importance of it. And that's going to be something that when you get to chapter 2, which I've already read, is heavily leveraged in this textbook. So if you have any struggle in that area or you want to understand why it's a good thing to do, this textbook might actually be a great thing for you so that you see how inheritance can be used in the game engine. But in this first chapter, all that's skipped because we need to get something implemented, and specifically that is a game of Pong. So if I hit Control F5, we can see the current implementation right here. This is the final implementation where after 2 additional exercises, it tells you to implement 1, the other paddle for the other player, and then 2 additional balls that come down. Now these ones are or extended problems from what is shown in a textbook, challenges for you to take on yourself. All you do is you create a simple game loop. We have a game class with an instance called game. We have whether or not initialization is successful, which gets handled by game, and then if it is successful, we run in a game loop until something decides to terminate it. And in this first chapter, what will terminate it is an SDL event to exit, which is like pressing the X button on the screen, or we will query the keyboard and the escape key at that time will then tell us what to do. As soon as that loop ends, we then go into game.shutdown. Now the shutdown component and the initialization component are incredibly important to make sure everything works. Initialization, there's a lot of things you need to request. You need to understand about SDL, setting up a window, setting up a renderer, getting all these things to work. And at any point in that process, it can fail. Also, it's just as important to be able to shut down and clean up all of your resources, which is why you also have a separate shutdown method. With C++, we're going to have a header file and a CPP file. The header file is simply going to declare our game class, a couple public functions that we see here, initialization, that loop, and then finally shutting the entire thing down, our constructor right here. Then under private, we're going to have three other things that are important for the overall game loop. That is processing input, updating the game, and generating the output of that. Everything else you see here, such as these null pointers and so forth, are pointers you get from SDL. We have a couple structs in here because we're not using an object-oriented approach yet. That is chapter 2. We simply use some structs and some loosely defined variables inside the class to control or contain most of the elements of that Pong game. I'm using an SDL rect, which is used to draw it. And here, of course, you can see we also create a very crude vector2 struct. Obviously, this doesn't have any additional functionality at this time that to really give it that robustness like multiplication, scalar multiplication, or vector times vector, dot product, cross product, all that good stuff. I think later in the textbook, I believe it's actually chapter 3, it starts talking about vector mathematics. And so we'll see whether or not we implement our own or if we're going to use an existing library. As you can see, we just have different variables like the paddles offsets or the heights and so forth. These things in a later chapter are going to be turned into classes, and then we'll create instances of them at a later date. So that's why it's a little bit messy in this first chapter. Now, the bonus part for this chapter is to implement a second playable character as well as create a vector of balls. And that allows you to have a bunch of different balls on the screen, or if you wanted to, add power-ups as well. So within our CPP file, we have the constructor. You can see here we're setting some null pointers up. We're making sure that this thing is running. Setting the starting ball positions are done here. This is bonus content, because normally you'd only be having one starting ball. In this case, though, I create a for loop for the number of balls that we have. A vector for each of those positions is created, and the positions of each ball are specifically based on the window width and the window height, as you can see here. So this way it creates all of them down that center, but then offset a certain amount. Well, offset pretty much the window height divided by whatever the current increment is. We have that +1 there because if we didn't, our first value would be a 0, in which case we would have a divide by 0 error. So be careful on that one. And then in order to give the balls different velocities, what I ended up doing was taking the window height, so where that object is going to be, multiplying that by 2.0, and then of course pi. This is going to give me all the radians around a circle. And if we feed that into a sine or a cosine function, you're going to be getting values between 0 or 1 and -1 and all the values in between. So that allows me to create velocities that are unique for each of these balls. So as we go and iterate through each ball, we're going to get a different sign for each one. And that means that they're going to shoot off in different directions. And I didn't have to hard code it myself. They're based on an equation. So if I were to add a lot more balls to this, such as, so let's actually come back here. Here we have starting balls. Let's do something stupid and do 25 instead. And I want to hit Control F5 and run this again. And then here we can see the craziness I'm actually trying to move of having 25 balls. So and you can see it runs just fine. I wonder actually, let's do something dumb. Let's do 100 balls. How about that? And see how it runs there. So Control F5. Whoa! We can see how they all kind of fan out from that central area, which is fun. There are no inter-ball collisions. I'm missing every single one of these, but that's fine. It didn't feel necessary to add. That would probably cause some crazy chaos on the screen too. I'm hitting the escape key to close that, by the way. We then have general initialization of the game. The book doesn't really talk at all about SDL much. It'll point you to the correct functions, but it's really up to you if you want to understand how these things work to go to the website and review the documentation. Here we're only setting up video. Later on in the book, we'll be adding audio, and we're able to create a window, so forth and so on, create a renderer, which allows us to draw to that window as well. And then here there's also this get ticks portion. This is important because it's going to allow us to use time to move our objects. And since, as you saw, we had balls bouncing all around, we actually need to know the time between each frame to know how much to move them as each frame progresses. So then we also have our run loop. In this case, it's a while loop that just processes input, updates the game's elements or objects, and then generates the output. And then we have shutdown. Just like initialization, here though, we're going to destroy the renderer window and then we're going to quit on out of SDL. Processing input is one of the most important things we can do in this game at this point. And all we're doing first is processing or polling for events. So as we pull these events off, they get taken off this list that we have until finally it's equal to no events. We've processed them all. We have to go through all of them to search them to figure out what the event is to then act on it. Here we're only caring about quitting the application. So we have a case, a switch statement with a case for SDL quit. The next part is to query the entire state of the keyboard, which you see here with SDL get keyboard state. We are then going to check a specific code. There are codes for all of the keys on your keyboard. You can specify whichever one you want here. If you happen to hit the escape key, is running will then turn to false. After that, we have querying for the W and S key, which move the left-hand paddle up and down. And then we have querying for the I and K, in which case that will then move that right side up and down as well. And this is kind of the beginning of what you need in order to solve the first extra assignment for Chapter 1. Our update loop, these first portions up here are simply handling updating time, getting that time, and then calculating the difference between the time now and the time in the last frame, which we can then use when we multiply anything by a speed, right? Because a speed is some unit of distance over time, multiplying by time gets rid of that unit on the bottom, and then we just have whatever distance we should have traversed. Now, all of this code here is pretty much duplicated twice. We could have done this in a function if we wanted to, and maybe not doubled everything up. But in the next chapter, I know we're going to move towards an object-oriented approach. So rather than waste my time cleaning this up, I'm just going to leave it here and then copy and paste this stuff over as soon as we start using a game object and a component-based model, akin to what you see in Unreal, as well as sort of what you see in Unity. So the paddles themselves, we simply check to see whether or not they have moved outside of the walls on the top and the bottom. Same thing with the balls. We iterate through all of the different balls that we have. And remember, we could have up to 100, which is what we just had. We go ahead and update their positions based upon those velocities, which of course require those delta time values. That's why we calculated those ticks at the beginning. Then we check collisions. And of course, we have to do this against the top wall, the bottom wall. Then we also have to check the left paddle. And then we also have to check the right paddle. Once we're done with all that, we should be good to go. Finally, once we've updated the state of our game world internally, we go ahead and draw that state to the screen with generate output. Here we have set render draw color. You always have to set the draw color before you draw anything to the screen, otherwise you'll be using whatever the prior draw color happens to be. We go ahead and clear our buffer, which is our screen right here. We then go ahead and draw all walls. We simply pass a reference to the struct, the SDL rect that we created. We do the same thing for the paddles, but in this case, we go ahead and calculate the paddles left and the right value. We have to cast them over to an integer value because we're dealing with pixels. We then go ahead and draw the balls after this, iterate over every single one, and render each of those out. And then finally, we do a swap buffer because we have a front buffer and a back buffer. We draw to the back buffer. When it's done, we then swap it at the appropriate time with the front buffer so we don't get any tearing. So how does this chapter rate? I have to say pretty highly. By the end of the chapter, you have a working version of Pong. Now, I have been doing this sort of thing for a very long time. So concepts like the game loop or vectors and some of the different mathematics that are necessary to pull these things off, I'm familiar with, I'm comfortable. So I wasn't ever really out of my element with this chapter. If you're new to C++, I could see how this one might be a little bit imposing. I had a similar book a long time ago when I was in high school. So we're going over 20 years ago. And the first chapter in the book was simply how to create a window inside of Windows, which was crazy difficult, at least for my beginner idea of how everything worked. I mean, it was explaining things that I had no desire to learn. I just wanted to get into the gameplay. This book does a pretty darn good job of getting you into creating something very early on. So, chapter 1, would I recommend the book? Yeah. So far, it's doing okay. Still too early to tell. We need to get a few more chapters under our belts. But I've already read chapter 2, and I've got to say I like where it goes. It gets sprites in there. You have a challenge where you have to create a tile set and then a tile palette, which will be really interesting. And we should be able to create some good 2D games by the end of chapter 2. And then chapter 3, I saw dives into some mathematics. So I'm interested in then getting some nice vector math in there and maybe creating some basic systems that will allow us to do things like proper collision detection in the future. I didn't like that they kind of skimped over some of the SDL stuff or maybe some of the setup, but I do understand why they did it. This is a printed book. There's only so much space they have, and they do expect you to have a certain level of familiarity. But once again, not for a beginner unless you've got a real fire and a passion pushing you to learn this stuff. Otherwise, I think you'd be better off learning C++ through an existing engine, maybe Unreal, or learning Java or C#, and then coming back once you've got your basic skills down. So next time we'll be looking at Chapter 2 and all the object-oriented wonderfulness that goes into making it work. I'll see you all next time. So long and goodbye.